All right, folks, so we are starting back in the notes on page 5, and what all this super fun factoring stuff has been leading up to is solving polynomial equations. So that's why we factored back in unit 4, because it's like, yep, the quadratic formula is not super friendly to use, but we want to try to find those exact x-intercepts. So that's what factoring polynomials is also leading us to, finding exact x-intercepts. So again, we have GCF, we have sum and difference of cubes, we have difference of squares. We now have quadratics and fake quadratics, which we can use the X method on, and then we have factoring by grouping. So folks, for these problems down below, we are going to solve these by factoring. Now what you'll notice is different about these problems versus the one we were just doing. Instead of just being a polynomial expression, these are polynomial equations. And what we've got is equals 0. So why do we factor? So that we can use the zero product property so that we can figure out what x is. So folks, taking a look at this first one, do we have a GCF? No. How do you want to factor this one if it goes 4 to constant? X method. So let's do x squared and x squared. What do you want to use for factors of 20 if the sum needs to be 9? 4 and 5. So multiplying in the x shape, 5x squared, 4x squared, and woohoo, that gives me the sum of 9x squared that I need. So these are my factors. So at this point, it's no different than what we did above. We've got our factors, or something times something. But it is now equal to 0. Now, before I go further, can we factor this further? Can I factor this as sum of squares? Is that a thing? It is not a thing. Only difference of squares, not sum of squares. So, folks, this is as factored as we can get. So this is the point in using the zero product property where we set each of these factors equal to 0. So remember, if I have something times something equals 0, one of those somethings has to be equal to 0. So either x squared plus 4 equals 0, or x squared plus 5 equals 0. Now, if I told you to solve these two mini equations for x, what's different about these versus the quadratics that we did back in Unit 4? It's got a squared with it, so we're going to have to square root, which we haven't done before. So I think Mr. Beal actually brought this up a little bit on Friday, and I'm like, oh, psych, they haven't actually learned this yet. So let's go ahead and move that 4 over to the other side. So x squared equals -4, and then we can do the same thing over here. X squared equals -5. Now, before we go any further in this problem, I want to just pose a question to you on what would happen if we had x squared equals 4. What's one thing I can plug in for x to make this true? 2. What is another thing we could plug in? -2. So when you square the x value to get 4, we are going to have both a positive and a negative solution that will give me that squared version of 4. So when I square root as an operation, we always include a plus or minus in front of our answer. And what is the square root of 4? 2. So the square root cancels out the squared with the x, giving us a single x, and we get plus or minus 2. So folks, as a general rule, whenever you square root as an operation, you have to include a plus or minus in front to account for both the positive and the negative solution. So this is kind of our why behind it, because positive 2 squared gives me 4, and negative 2 squared gives me 4. So anytime you square root, got to put a plus or minus in. So that takes us down to this one. We've got our x almost isolated, but now it's square root time. Now when I do this, x is equal to, the first thing that we put in is the plus or minus. plus or minus. What's the square root of a negative? Oh, there it is, coming back to haunt us from term 1. It's I. And what about the square root of 4? 2. So my solutions are plus or minus 2I. So if those are my x-intercepts, can I see them? No, they're still algebraic solutions, though. I can still solve for them and find them, and they would still give us 0 when we plug them back into the original equation, but they don't actually exist on our coordinate plane. So then, what about on the right side? X equals plus or minus, because we square root. And what's the square root of a negative? One more time. I. Can I simplify the square root of 5? Is it a perfect square? It is not. So that 5 stays underneath the square root. Gross. How many answers did I just find?
1.
More. Huh? 4. Positive 2i is 1. Negative 2i is 2. Positive I rad 5 is 3. And negative I rad 5 is 4. So that's a total of 4 solutions. But how many, real graphable x-intercepts does it have? None. So the i's make these x-intercepts we can't see. So you can write no real x-intercepts. But we still found a total of 4 algebraic solutions. So it's important that we include our plus or minus because that's all the difference between having just 2 solutions and having 3 solutions. So let's go through that one more time. The problem says to solve by factoring, so check for a GCF first. We saw that the structure looks like a fake quadratic or 4, 2 constant with the powers. We used our x method and then we got it into factor form. So factor times factor equals 0. We set each of those factors equal to 0, and then we solved using our new fancy square root rule. So let's rewind, repeat. Let's repeat on problem B. Do we have a GCF on this one? No. It has the structure of a fake quadratic. We go 4, 2, constant. So let's go ahead and try the x method on this one. And I'm going to let you struggle with this one a little bit. See if you can break it down into its factors. Go ahead and take a check up here and see how we did. So not super bad because we didn't have to do any sign adjustments here. We get 1x squared times 2 is 2x squared, 3x squared times 2 is 6x squared. Add those together to get the 8x squared, no sign change necessary. And then we go straight across for our factors. So these are my factors. And if we're looking for the x-intercepts, we want to know when this is going to be equal to 0. So if I have something times something equals 0, one of those two somethings has to be equal to 0. It's the only way for me to get a product of 0. So either x plus 2 is 0 or 3x squared plus 2 equals 0. Now, folks, it was a little bit easier to not show this step when we were doing quadratics because it would have just been like -2 and -2/3. Here, I would like you to explicitly show this solving work. So from here, we subtract the 2. So x squared equals -2. Square root. And x equals first. What comes after that equal sign? The plus or minus, then what? The I. And then remember 2 is not a perfect square, so that's going to have to stay under the square root. So plus or minus, I read 2. How many solutions did we just find? 2. Positive I rad 2 is 1. Negative I rad 2 is another. How many solutions can we actually see? No. So because of that I, we wouldn't actually be able to see these on our graph. So let's go ahead and try this last one. Oh boy, so we're going to subtract the 2. Folks, why don't we want to square root right now? Because of the 3. So my x squared, the thing that I want to square root, is not fully isolated. So we want to actually divide by 3 next. So goodbye. So x squared equals negative 2/3 square root. And x equals plus or minus. What can we definitely do with this? Take out an I. Now that square root of 2/3, I want you to just put a note that says, will simplify unit 7. So we will simplify in unit 7. So square roots of fractions, bit nasty, bit beyond our breath right now. So we're going to go ahead and just leave it in this form for right now. All right, folks. So we're adding the solving step still in the context of factoring. Now, if we were looking at the next one, there's no GCF, is there? No. Anything jumping out at you about x to the 4th and negative 16? So there's no x squared. So you could either factor it as a fake quadratic using this setup, or what's special about 16? It's a perfect square, and x to the 4th is also a perfect square. So what this means is we can factor this as the perfect square factors of x to the 4th, and what would those be? X squared and x squared, and my perfect square factors of 16, 4, and 4. One gets a plus, one gets a minus. Can we take this equals 0 a little bit further with our factoring? Yeah, because what is x squared and 4? We got difference of squares again. Can I do sum of squares? Is that a thing? So we'll have x squared plus 4, and then x plus 2, x minus 2 equals 0. Ooh, so we have 3 factors. This times this times this equals 0. That means one of those factors has to be equal to 0. So subtract the 4. X squared equals negative 4. Square root. X equals, see if you can write your answer. What's the square root of negative 4? Plus or minus comes first. What comes next? We're going to write it as 2i. So we could take out the I, but since 4 is a perfect square, we would want to write it as 2i versus I2. So coefficient in front of the I. Gross. Now, what about over here? We subtract the 2. Do I square root? Why not? There's no squared. It's just plain old regular x. So then x equals negative 2, and x equals positive 2. Folks, you can get out your calculator if you want, or actually, no, just go ahead and just follow along with me up here. If I went to my y equals and typed in this equation, What do I know about this graph? Remember even degree? Even degree positive leading coefficient goes up and up. Even degree negative leading coefficient goes down and down. So it should look like this. If you're like, I forgot all that stuff, Miss Carl, that's okay. That's why we have our calculators. But just FYI, we would be able to tell from looking at the equation what that end behavior should look like. But the big thing is, what do we know about the x-intercepts? There should be 1 at -2 and 1 at +2. So if I hit graph, swoosh, swoosh, here's the one at -2, and here's the one at +2. Now let's say I'm thinking it looks pretty close, but I'm not sure. You can use your trace button to verify any input. So if I hit trace, that engages the x equals y equals, and if I type -2, boom, we see we get 0. Hit trace, type +2, and I see that that is also 0. So what we're going to be doing in the next section as we start figuring out what to do when we can't factor or what to do when my graph only shows one of the solutions is we are going to see how the interaction of the graph and the equation and its factors are all interrelated. So let's go ahead and go into the blue packet, into the guided practice next.